that will review that with you in a meeting, maybe separately, and so several weeks later you maybe finally approve that document, and then finally you can get to writing the code, and then you spend a little bit of time writing the code, and then you have a question, so you're gonna have to wait on someone else, or maybe you need something from someone, so you're gonna be doing a lot of waiting and chasing people down. And when finally you have completed your code, you have to merge it, but maybe you don't have the right tooling, maybe it's a long-living branch, so you're going to have merge conflicts. So you have to resolve those, sometimes maybe even start over, just because they're so hard to resolve. Once everything is merged into a trunk or master or main, you're going to have to wait for the user test to be completed. So it's going to be deployed to QA, or some people call it staging. And then people are going to go through the various scenarios, and they're going to tell you whether everything is good. And they're going to come back, and they're going to have a list of missing requirements, right? They're going to say, oh, but we forgot this and that doesn't quite work now that we see it in action. And then after you go through that list, somebody that you never heard of in the organization emails you out of the blue and disagrees with the requirements that you have already finally implemented. So now you have to do a complete redesign, right? But that's not over, because while you're writing the code, even within that green, the good part, you still have a lot of technical depth. You can have 20 levels of inheritance, so you have to chase down, extends, this and that, to try to understand what is happening and which one of the parents has the method that's being called. Then the methods have 800 lines, maybe thousands even. You have these arrow sort of ifs, 6 or more levels of nested ifs that are very hard to wrap your head around. And then once you sort of understand the code, you don't know how to unit test it. It's not testable, and maybe you don't have much experience with tests. And then you have to understand, while you're testing it, you're trying to understand the code, is that particular variable currently null? Do we have to check for a null here? Because of, optional arguments and things that can return nulls everywhere. And also, great variable naming. What does array2 contain in that particular context? So yeah, there's a lot more than just writing the code. So in a context like this, I would say that nothing ever gets done. These are, many companies, they are on an annual release schedule, sometimes quarterly if they're lucky. So we're not talking about continuous deployment here. So how can we get to the good part faster? And how can we trim the fat from this process? And this process is by no means, by no means only applies to the big enterprise. I've seen this in smaller companies as well. It's the kind of thing that just grows over time and becomes very, very tedious and introduces a lot of friction. So how can we put less effort into writing the code and actually get a better result? And also, why should you listen to me? Because I've been coding since '97. I've been doing PHP since 2003. I call myself a legacy archaeologist because I dig into old code bases so that you don't have to. I love test automation. I give talks and workshops. I have some YouTube videos for you to watch. And I own Filina Consulting, which is a very original company. So let's look at ways to make all of this much simpler. So the first part is writing better specifications. So we all complained about specifications in the past, right? We all know that they're bad, but can we just blame them on someone else? Is there an actual solution? Instead of just throwing it to someone? Well, let's try to understand the process of acquiring those requirements. So we sit in a room and we discuss the requirements with a bunch of people. Well, these times we sit in a Zoom meeting. And then at the end of that, we will emerge with a 50-page document, okay? Because we're going to draw diagrams, we're going to explain in words everything we need to do. try to cover all the edge cases. But the documents may not even give enough context to give us all the answers. It also becomes outdated, and it might probably rot in the company's Confluence or SharePoint or Google Drive. But despite that, we can start development, hoping that this is enough. And then we have a question about one of those requirements. And so we spend a lot of time waiting to get an answer. So all of that is time that we are not working on this. Our other option is to work on something else in the meantime, so we have to constantly context switch. And getting an answer can take some time, because it can involve email chains with dozens of people who have all different opinions about what the answer should be. And once all of that is done, somebody will test it and will give us, the list of requirements that we missed. That basically were never explicitly mentioned in the 50-page document. And then, of course, we're going to have another question, and there's going to be more testing, and we can just go like this for months, maybe even years. And even if you put that into sprints, you're just going to repeat the same process over and over again. It's not going to get more efficient if you add sprints. So a better solution is, well, first of all, I would say get a product owner. That is possibly the best thing you can do for better requirements. So the product owner will be the go-to person for all the requirements. So that person's entire job has to consist of talking to the different people to understand what the system needs to do. So they're going to talk to the users, to the various managers, whoever has a stake in that application. And that person will also ensure that all of these people don't contradict each other, because everybody has an opinion. So you can get one answer from one person and another answer from someone else. Now, this product owner will take care of brokering all of that between those people, and will give you sort of a final answer. And so it's not enough to just have a product owner. You gotta make sure that you have direct and quick access to that person. It's not the kind of person that you would email and you would wait 2 days to get a reply. They should be pretty responsive. Also, it helps if they don't have any other roles in the organization, because if they're wearing too many hats, they're going to get busy. They're going to start delegating things, because they should not delegate questions. Because if they delegate the questions, somebody will give you an answer that they haven't checked with everyone else, and so that might not be the final answer. And so you would be working under the incorrect assumptions. So the requirements will not be very good. And one great thing that you can do is communicate those requirements with them using acceptance tests. Because without any sort of tests, everything they say will be vague and subject to interpretation. Now, acceptance tests are pretty easy to write. So they're written in Gherkin, which is a format for specifications. So now we're getting to the good developer part. So this is a scenario. Let's say a user can subscribe to a service using a credit card. So like you have a software as a service, you have various plans, and they can subscribe with a credit card. So as a user, I selected a membership option, so one of those plans that you have online. When I enter valid credit card details, then I should see a payment receipt. Now, here's what we've done here. Obviously, you can have more than one of each. You can have multiple givens. You can have multiple when. Well, actually, you should only have one when. You can have multiple thens. But usually, I keep it to one when and one then, where you can have many givens. So given this condition, given that condition, given another condition, when I perform an action, then I have some observable behavior. And it's very important to have an observable behavior. So writing something to a database is not something that a user can see. So if you go shop online and you put your credit card into the system, you don't care that they wrote your database, because they can just turn around and say, we don't have anything in the database. You say, yeah, but I paid. My credit card has been charged. So if you wanted a refund, for example, what you would do is you would show them the receipt. The receipt is the ultimate proof of payment. Once you see a receipt, you are convinced that everything went through, that your item will get shipped in time. You don't have to worry about not having successfully completed that operation. So we know that that transaction has succeeded. So this is very sort of tangible, observable behavior. And this is very simple, and it can be automated. The execution of this can be automated using something like Behat or Codeception that can read those individual sentences and convert them to code that can be executed. So this now becomes your happy path. So a happy path is where everything works great. We can have other scenarios, for example, for invalid credit cards, and that would be, an alternative path or an exceptional case. So this is one of the use cases. You don't have to focus necessarily on user interactions. So at first we had user interactions, but you can do something that is, more from the perspective of the system, where you can maybe audit some business rules that need to be auditable. This is particularly important in financial institutions, but can also be useful if you have some complex calculations that have to be respected. So discounts are matched based on the current date. Given a 5% discount, and you give it a name, which is 5, which should be something that is readable instead of giving a big code that doesn't really need to be complicated for the purpose of readability. So a 5% discount named 5 is active on basically between January through the month of January of 2019. A 10% discount is active in February of 2019. And the current date is January 15th. When I check for discounts, then the 5 discount should be found. So we give it basically 2 different discounts, and we want to make sure that based on the current date, it finds the right one. Now, these are not unit tests, right? Unit tests can be sometimes similar if you have those scenarios that are very granular, but they serve different purposes. This is for the purpose of communicating things clearly with your product owner. And once you've communicated that clearly, they can be executed. And then when everything passes, you know that you basically have achieved the acceptance criteria. So requirements then become a collection of use cases that need to be accounted for. So if you write everything as use cases, once all of these pass, you can be sure that you have done everything that you're doing everything that the user wanted the system to do. So make sure you always use also natural language. Try to avoid programming talk. Don't talk about files. Don't talk about databases. Try to talk as much as possible in terms that don't imply any sort of implementation. Right. So let's see what happens when we take the same process that we had for requirements, but instead of using a document, where a very verbose analysis document, we can use use cases. So at the end of this meeting, we discuss and we emerge with some use cases, some of those scenarios. And the thing is, they don't have to be exhaustive. So you don't have to have all of them written down in advance. You can cover the big parts, and if you have some edge cases, maybe something where people need to have a little bit more discussion, maybe ask other people that weren't in the meeting, and you can just leave them for later. You can still have a pretty solid start, and you can start developing knowing that you might have to account for this or that use case. So, and if you think that management is impossible to convince to use use cases, actually successfully in a pretty large bank, I successfully introduced this approach. It's a bit of a crutch, as I would call it, but it was a good first start, because these people, they love diagrams. They can read diagrams. It's easier on the eyes. It's just more familiar. So the exact same sentences can be represented differently. Can be represented like a sort of flowchart. And if you provide this to them, then you can validate that you clearly understood what they want you to do. Then just go ahead and copy paste that into your scenario, and write everything you need to execute them, and then write the code to make those scenarios pass. Because yeah, everybody loves boxes and arrows, and eventually what will happen is they will start providing those themselves. So you wouldn't have to translate what they say into those diagrams. They will be able to draw them for you. They will come into the meeting fully prepared, all of their use cases ready, because they would learn to think in that way. And then when you start developing, which is really great because you reduce the number of issues right away that come up in user testing, but you can also postpone decisions, because yeah, those scenarios that we haven't had a chance to confirm initially, if you have a question, also you ask for basically another scenario, which is a much easier to produce than a detailed answer. So a scenario is pretty much a low-hanging fruit. And then you go into testing, and you have a lot less issues. So in one application that where I introduced that, where in the past this company had dozens and dozens of issues that took another 3 to 4 weeks to resolve, sometimes more, because of the long test cycle. We reduced that. We had one bug because the use cases, when they're executed, they are sort of high-level tests, so they integrate every part of the system. The only thing we had is because a microservice was improperly documented, and so we sent data to it that it didn't interpret the way we thought it was going to interpret. So it's just more of a contract issue with an external system. But within our system, everything was fine. So this will allow you to cut a lot of time out of gathering the requirements. Now the second part is iterative design. If you do all of your design upfront, it's going to be very hard to adjust in case we make a mistake in the design, because obviously we all make mistakes. We all know a lot more about the problem once we start, getting our hands dirty. But in advance, it's all theoretical. It doesn't really click as well. But you have to be careful, right? Because the problem is not that we spend any time on design. The problem is that we do everything before we write a single line of code. So we have many assumptions that we can't really validate. Once we start validating, all of this hard work can fall apart. Let me show you an example. Let's say you spend a few weeks designing the application. So you think about the class structure, how the components will interact. And then you try to get that approved by the right tech people, which can take some time as well. Then you start coding, and then you start finding cracks in the design. So the design doesn't quite work the way you thought it was going to work. And this is especially true in legacy code, because you don't actually know what's happening under the hood. And it would take way too much time to explore every single line of code that might be affected by it in order to create something that is bulletproof. So yeah, if you make a mistake in the design, everything falls apart, and you go back to the drawing board. So this model really assumes that you can't know everything in advance, and you can't, because, as Alfred said, the map is not the territory. So what happens if our plan has a mistake or doesn't account for a detail? Well, we need to be prepared to adjust. So what we do is, instead of adjusting after the fact, we put that adjustment into our process itself. So what we do is we start with something very lightweight, like a sequence or activity diagram. So if you have multiple use cases to represent on one diagram, you can use the activity diagram. If it's just a single use case, then you can use a sequence diagram. I'll show you some examples. So once you have a diagram, you can then write minimal code to validate that design that you just did. And then what will happen is that when you validate this design, you can go back to the diagram and modify it. And you can go back and forth very quickly. It's not like doing a huge design and thinking about all the classes up front. So information can flow both ways between the design and between the diagram and the code. So information you gather while doing things that you understand while doing the diagram can help you with the code. Things that you do in the code can help you improve the diagram further. So you just go back and forth until you have this minimal code that you can look at it and say, yeah, I like the way it feels, like the usage is very good. It's really easy to understand. And now we can worry about the implementation details. So it prevents us from spending excessive time on the details that may prove wrong in the end. So here's an example of a sequence diagram. So I like to split it by application boundaries. Other people do it differently. So I have a user, the UI, the API, because it's the back end is the API. The React or Angular or Vue.js application is the UI, and then you have the user who initiates the interactions. And then, for example, you can have other third parties like a payment gateway in case of a payment. So what we do here is, going back to our scenario that we wrote in the beginning, the user selects membership in the UI, but the UI then creates an order with the product code that we selected. So the UI sends this HTTP request to the API. The API does its thing and returns an order. And then with the order, the UI can present a payment screen to the user. So they're going to be able to fill in the credit card details. So they enter the payment details, and then the UI sends a finalized order with the card information to the API. And the API processes that, and after a while returns a receipt. So, and that is your receipt, right? Then I should see a receipt. And so that is what we send to the user. And so once we have that, we can write the code. So this takes all of 5 minutes to create, maybe 10 if you have to look up some information, but most of that information is already in the original Gherkin code that we wrote. So you kind of translate it to something else while adding some extra information, such as how would you call the endpoint, to the API, and what kind of data you will need to supply. And that also kind of sets the contract between the UI and the API. Like, okay, so this endpoint needs a product code, or this endpoint needs some credit card information. So once we're ready to write the code, many people, what they'll do is they always say, there's too many cooks in the kitchen. We cannot be 2 developers working on this feature. And people have told me that for features where you could have 5 people working, that's because people cannot always intuitively separate the work very well. They're always afraid to step on each other's toes, afraid to work in the same classes, afraid to duplicate any efforts, and also afraid of eventual merge conflicts. But the solution to that is to first do mob programming. So the entire team, and usually I hope your teams are 5 people or fewer. Large teams may as well be split into multiple teams. So mob programming is you gather in the same room and you spend half an hour to an hour validating the design. So one dev basically shares the screen and you start coding. You start coding based on what you see in the diagram, and you try to figure out what kind of pieces you will need and how they will fit together before you decide exactly how the pieces are going to work. And then once you have the design, you split the work into implementation of the various components that you designed and the test for those components. So for example, if we go back to this diagram, if we want to focus on one endpoint, so this would be an endpoint, right? The UI sends a request to the API, create order with a product code, and that returns an order. So that will be one action. So we can write a create order handler, for example, and that will have only one responsibility. It will be to handle the request for creating an order, given the product code. So, if you use an MVC type framework, this would be a controller, and the create order will be a single action within that. Although I do prefer frameworks that use this approach where it's just one class per action. It just reduces the number of dependencies you have to load. So what we do first here, basically what it does is it receives a request, it returns a response. So if we go back to the diagram, right, we have a request and we have a response. So it's pretty simple to wrap your head around. So what you write here is you try to get a product code from the request. So request get attribute product code, and then you put it into a class called product code. And this class here is a value object. So it's an immutable type of object, and I can show you how they're written. So make sure that this product code is valid, but also that in the future you would never have to check whether it's null or false or empty, or the string is too short or doesn't satisfy some sort of requirement. So if your product code must contain only letters, number, and hyphens, you can enforce that with the product code. So basically, you cannot instantiate a product code unless the value that you provide as the argument is valid. So once it's valid, you are guaranteed, and you can start passing this code around instead of just a plain string, which might end up empty or modified in the future. So sort of guarantees this validity throughout the rest of the execution. And so the second part is we get the product from wherever the products are. So it will be some sort of products repository. We don't have to worry exactly about what that is. I mean, it could be a database, it could be a CSV file, it could be a microservice, it doesn't matter. All we know is that we give it a product code and it gives us a product back. Okay, so we're just doing, this is the design phase. And then the next part is we have orders, which is similar to products. We don't know how they're stored right now. We will decide that later. And so we create an order by giving it a product object, and then we get an order object back. And then what we do is once it's done, we can return the order. We can just to array it and then return some sort of JSON that is suitable to us. So this is just a simple example for the sake of brevity, but you don't have to figure out every single field also that goes into the order. You can just worry about that later. So that sort of gives you the feel of what kind of components you will need. You need some place to store your products. You know that you need some place to create your orders. So you kind of start integrating components without actually having written any of those components. And so it is actually worth spelling out the complete handler when you're doing more programming, because it doesn't take a long time. Because it should be as simple as possible, usually 10 lines of code or less. So what you're doing here is you're putting all the glue that holds everything together, and it will guide you through the rest of the work. Because note the dependencies here, you have the products and the orders. Now, you know that you would have to inject them through dependency injection. You'll have to inject them into your constructor. So the constructor for this handler will look like this. You will have some sort of product storage or product repository and order storage, right? And these will actually be interfaces at this point. So I highly recommend that you make them as interfaces, because then you can further postpone some of the decisions about implementation. And you can actually start unit testing the entire application. So again, with the entire team, you will define the interfaces. But most of that is already sort of clear just by looking at the handler. So we know that we receive a product code and we return a product object. And the order storage creates an order by receiving a product. So now we just need to figure out these remaining 3 classes. These classes are also relatively easy to write. You don't have to write validation just yet unless you already know the information. That can be part of the sort of implementation part. But you can at the very least create the constructor, that receives the code, and some way to get the code. So basically, all the functions that are used within that handler it will exist in one way or another. Right. So we will later refine this object. We will add tests, things like that. Now, so all of this effort that we did, with small programming, we actually wrote 13 lines in the handler total. We wrote 8 lines in the interfaces. We wrote 46 lines in the value objects. So that's a total of 67 lines. That's all it took. So that can be done in half an hour to an hour. It's more discussion than actually writing code. And that discussion is very important because then you get a shared vision of where it is you're going. And then what you do is you take that and you can merge it to master because it doesn't interfere with any existing features. So for now, nothing is going to be wired into the application. So nothing is going to be registered in the router. So there's no risk of breaking anything. However, if you are in the process of extending existing behavior, then you have to explore something called feature flags, which basically you will be able to enable those paths, those execution paths towards the end. So you kind of hide them away. They're only available through tests. And when you're ready to merge, then you just remove them once at the end and do one last commit. Right. So, and then you split the work. So you split the work. One person is going to test the handler because the handler is already implemented. I mean, you just have to write tests for it. And because you have interfaces and there's dependencies, you can just mock those. So you don't have to worry about them at all. So if there are any, ifs or loops or exceptions within that handler, you can start testing all of those cases. And maybe think of new cases that you didn't think of while you were with your team. After that, another developer during that time can completely independently implement interfaces and the tests. And you can even split, one person works on the product repository and the other person works on the order repository and perhaps defines the value objects at the same time. So the value objects are, the things that we pass around, the product code, and the, the order. So another person can implement the validation of the value objects, write tests for them. Somebody else can write the steps of the acceptance test because those have to be implemented by a developer. So already you can have so many people working together. And if you need to make some changes to the design, if you discover that some things don't quite work in the end, you just go ahead and you can make the necessary change, update any tests, commit, and everybody can just rebase and continue working as though nothing happened. Because your interfaces are so simple. And so, for example, if you need to add a new argument, to your order storage, so you have a product, but you also now need to have a country in there. Well, you talk to the team, and then you send a patch, and then everybody rebases their branch. Make sure that the country is passed to the create methods for whoever uses the create method, and then they just continue working. So it's pretty painless. And of course, I mentioned the acceptance tests. So you can do, for both backend and frontend, something like Selenium, or if you want something that is maybe a bit more user-friendly, less for developers, Testcraft, I think, is pretty good. I saw the video, really excited about it. So it's called Testcraft. Or you can also do just for the backend. So basically the front-end developer tests their own stuff and the backend developer tests their own stuff. And maybe a couple of tests, to make sure that the integration between the backend and frontend works well. What you choose really depends on which parts of the app you control. If your repository contains only the backend, then you have no business writing tests for the frontend. You just make sure to satisfy the contract that you have with the front-end developers. So in our case, if we have a backend only, we'll just send HTTP request to the API. So what you do, you commit those scenarios into your code base. but you prevent them from running by adding a work in progress. So you kind of exclude all the scenarios which are work in progress. So this is your feature that you're currently building. And then what you do is for every line, you basically call a different endpoint. So the given here, I selected the membership option. Remember in our sequence diagram, we had two interactions with the backend. One to create the order, which is, I selected the membership option, and entering the payment information, that's the second call. So all of this is kind of symmetrical. All of this ties together very nicely. It's just a different way of looking at the same thing. And then the last one would be asserting the response from the second call. So once you receive that payment confirmation, then you can assert details about that. And so what you do is the person who writes the acceptance test, because obviously, the first endpoint and the second endpoint are not necessarily complete by the time they're done writing the scenario. So what you do is you remove the work in progress tag, run it, make sure the first one at least passes the first step. Then if it fails on the second step, you put the tag back in, and so you keep doing that until all the parts catch up and you're all in sync and everything is green. So once all the steps pass, it means that you are done. And you can remove the work in progress tag, and you can just do one final commit, and that's it, mission accomplished. That use case is now satisfied, and you have a test to prove that it's satisfied, and you have a test that can be read by a non-technical person too, so it's good proof. And you can cash in on those story points. So what have we learned throughout this presentation? So your code is living documentation because you have your tests in it, you have your Gherkin scenarios in there. So the code is not in Confluence or somewhere else. The documentation is not in Confluence. The documentation is right there in the code. And the documentation that kind of documentation cannot get out of sync with the code, because if the scenarios change, they will no longer pass. So it's like self-validating documentation too. While I'm talking to people all the time who say, well, we had this documentation and I look at the code, it doesn't reflect what the documentation says anymore. So it sort of became outdated, and that's very often the case, especially if you have really a lot of it. So by writing scenarios this way, you make sure that you actually keep your documentation up to date, and that not only the code is valid, but the documentation is also valid by definition. So the other thing is, don't try to figure out everything up front. So beware of all the unknowns. That's why we do iterative design. You do a little bit of, you set some of the, you write code, minimal code to validate your design, and then you continue. So don't try to know everything before you write a single line of code. So mistakes are also normal. Basically, fail fast. Don't worry about mistakes. That's just part of development. Because they're going to be so cheap, you're not going to worry about them anymore. And you'll be able to move a lot more quickly if you're not always worrying about having everything perfect before you commit anything at all. And also make sure that you work together more often with other people in your team. So mob programming, peer programming, like I peer program for things like I don't know what to name a variable. I don't know how to name a method or a class. Or I have a few classes and they're kind of convoluted. They don't make sense. So I would go to another developer, and I will just have this conversation with them, because maybe some new information will come out of that, and maybe we'll completely refactor all of this because we would realize that one of the intermediate classes just creates indirection and is completely redundant and can be deleted. So it is very useful in refactoring the code, learning, and also writing code that is self-explanatory, code that you can read basically like English. And other topics that I would like you to look at when you're done with the conference. Look at domain-driven design. So I already talked to you about interfaces and dependency injection. Well, mostly value objects and services are part of the domain-driven design. Test-driven development, so write the test first, write your code afterwards, write failing tests before, then red-green refactor, so failing test first, make it pass by implementing the necessary code, and then in the end refactor to make sure it's all clean. Acceptance tests, so we talked about that. Solid principles, I started a video series on YouTube. I haven't quite had the chance to finish it, but I will be working on it soon again. So the solid principles are very important, they're very useful. If you follow them, you will have much more maintainable code, but also it will be easier to write, like it would basically write itself. Also, there are plenty of books on clean code, so read up on those. Extreme programming, so every time I talk about, working together, pair programming, multi-programming, this is all part of that. And I kind of stealthily introduced Scrum, with POs and stuff like that. So do look at Scrum. There are a few good books out there. I was very skeptical at first, and then I read the book and it just made sense. And I took the parts that made sense to me, because that's the whole point of Agile, is you take what you need, your whole process has to be adaptable. You don't just slap a process and hope it works. So yeah, all of these things together helped me to write software really effortlessly. So just yesterday, I started working on a project in the evening, and I was done, after a few hours. So it's just, as I said, it's code that writes itself. So that's it. I will take questions. By the way, I will put those slides online after this presentation. I will tweet the link, and I'm not sure whether there will be video. The organizers will confirm. So via Twitter, you can also DM me. So my direct messages are open. So if you have further questions, you can also ask more in private if you'd like. Thank you. So how do we proceed for questions?
Thank you, Anna. I'm going to tell people now that they can ask questions. If necessary, I will translate them in text. Pessoal, se vocês tiverem alguma pergunta, vocês podem fazer agora, tá? Eu vou pedir a gentileza que vocês façam pelo chat, tá? We have a question already, Anna. Did you saw that?
Oh, I was looking at the Q&A section. Sorry.
Oh, no worries. People are talking.
Can I use Behat to do scenario-based testing? Yes, that is precisely what Behat can be used for. Oh my goodness. I have to sort through languages that I know, first of all. Okay, I'm catching up. I already follow on GitHub. Okay. Can you talk a little more about Testcraft? Did you recommend it? Testcraft is, I haven't used it myself, but I saw a video and it just looks awesome. So I just got really hyped and wanted to share that. Basically, it allows you to, I think a bit like the WebKit for accessibility, sort of analyzes your site and allows you to, instead of coding, the different elements that you want to interact with, you basically just click around and it records it, and you can adjust the little criteria. And it can also be smart enough that when your design changes slightly, so if your HTML has moved a bit, if it uses slightly different classes, it can adjust. So there's a little bit of AI there. I would really like to explore more, and I think this is pretty much this would pretty much be the future of testing. But what it doesn't allow you to do, so both Selenium tests and these kinds of UI tests, they're not the same as Gherkin, right? Because with Gherkin, what you do is you specify, I mean, there's probably a way to sort of make it work, but what you really want to do is start with something like BHAT or Codeception, where you can define exactly, you know, not the steps in terms of technology, but the steps in terms of the use case, right? So I select a membership, you know, what does that actually mean? So you have to translate that then to code. So the translation can be done using any technology, but if you really want to use, you know, behavior-driven development, you got to start with anything that uses Gherkin. That will help you communicate those requirements. Does that answer the question? Whoever asked it. Okay, got it. In the mode programming, when should we stop? After a time, after the main handler is mostly done? Were you sure? This is, so is it when everybody is in sync about the feature? I mean, you kind of learn to work with your colleagues and get a sense of what works, what doesn't. At first, I think you might spend more time than necessary, and then you will adjust. You will realize, well, you know, this is more than what we needed to know, right? So you kind of will learn to think like the other person. So you will adjust. I usually recommend, you know, capping it to no more than 1 hour, because after an hour it becomes difficult to sort of focus on stuff, and it becomes more, you know, free-form discussion. So try to accomplish as much as you can between 30 and 60 minutes, and after that, you can always reconvene later, because you're going to have plenty of time for meetings if you follow this process. Your schedule will be free. Does that help? Okay. When you told about scenario without BDD, I saw them in my last job. Yes. Yes, those, you know, the before and after is really to get people to identify with those situations. Any other questions? We still have 5-10 minutes.
Pessoal, mais alguma dúvida? Vamos lá. Aproveitem a presença da Ana aqui conosco. Nenhuma outra dúvida, nenhuma outra questão?
I find that every time I make this presentation, it becomes shorter and shorter.
Oh!
I don't cut anything out. It's just I get a better pacing each time. I manage to condense things.
Right. I know what you mean. Yeah.
Do I recommend any book about it? What is it exactly? I can recommend many books. Which topic exactly? Oh, BDD. I don't think I've read any books on BDD actually, but I will write it down and I will tweet about it. And that way you'll have the answer. So it will probably take me several weeks, because I will have to find the book and read one, and then I will be able to recommend it. Okay. Or I can cheat and just ask Twitter what they think.
Pessoal, mais dúvidas? More questions? Going once, going twice. Anna, thank you so much again for sharing your time and knowledge with us. And we will proceed then to Erica's